In this video here, we're going to take a look at the inverse of a linear transformation. Now, before we look at finding the inverse of a linear transformation, we need to just recall two important results from the previous chapter on matrices. So for a 2 by 2 matrix given as A equals A, B, C, D here, the inverse is given as follows. So A inverse here then, this is equal to 1 over the determinant of A here, so that's this det A. And then what we do here is we times this by this matrix here, this 2 by 2 matrix, right? So we have D minus B minus C and A there. So that's for the inverse of a 2 by 2 matrix. What about a 3 by 3 matrix now? Well, not quite as straightforward here. So for a 3 by 3 matrix, let's call that A here. The inverse is given as follows. So we have A inverse again, right? And again, we have 1 over the determinant of A here. And then what we do is we times this by C to the power of T here. So C to the power of T, this is the transpose of the matrix of cofactors. So we do have separate videos here regarding the inverse of a 2 by 2 and a 3 by 3 matrix. So if you're unfamiliar with these topics here, what I'd recommend then is that you just go back, quickly revise and pick up those topics there just before you continue with this video here on the inverse of a linear transformation. And just note then that it's often easier to just use your calculator when finding the inverse of a 2 by 2 and a 3 by 3 matrix. And that is the approach that we will use throughout this video. So it is important that you can do it by hand. So ensure that you can find the inverse of a 2 by 2 and a 3 by 3 matrix by hand. But for this video here, and often for exam style questions involving the inverse of a linear transformation, it's just often easier to just use your calculator. Okay. So how does this link then to the inverse of a linear transformation? Well, the way that this links then is by the fact that we can use an inverse matrix here. So the inverse of a 2 by 2 or a 3 by 3 matrix, depending on whether we're working in 2 dimensions or 3 dimensions here, to represent the inverse of a linear transformation. Because we know that A inverse times by A here gives us the identity matrix, right? So by using the inverse of a 2 by 2 and a 3 by 3 matrix, we can easily find the inverse of a linear transformation. So if we formally define this here, then the transformation that is described by the matrix A inverse here, this just reverses the transformation described by the matrix A, right? So hopefully that sounds quite intuitive, right? Just using inverse matrices here to represent inverse, or the inverse, I should say, of a linear transformation. So there we have it. That gives us everything that we need here then for our introduction. Let's take a look now at a couple of practice questions here for the inverse of a linear transformation. So let's get started here then with question 1. So for question 1, we're given this 2 by 2 matrix P here, and P is equal to 3, 0, 0, 3. Now for the first part of this question here, part A, it just asks us to state the transformation represented by the matrix P here. So hopefully nice and straightforward here just to get us started then for part A. So for this matrix here then, this is of the form of A, 0, 0, A here. Okay. So this matrix here then just represents an enlargement with center 0, 0 with a scale factor of A here. So in that case then, we have an enlargement. We have an enlargement here with center 0, 0, center 0, 0, with scale factor of 3 here, right? Because A is equal to 3. So with scale factor of 3. Okay, and there we have it. So nice and straightforward. That gives us the solution there to part A. Now for part B then, again, hopefully nice and straightforward here. It just says using your calculator, find P inverse here. So that's this P to the power then of -1. So obviously, if you know how to do it using your calculator, just use your calculator. If not, you will have to do it by hand, but this is just find the inverse of a 2 by 2 matrix. So it should hopefully be nice and straightforward either way here. So what we get then, if we just use our calculator to do this then, again, we get another 2 by 2 matrix. So we get 1 over 3, 0, 0, and then finally 1 over 3 there. Okay. And there we have it. So nice and straightforward. That gives us P inverse there. And then finally here for part C, So we're then told that the point xy maps to the point 5, 6 under P here. So for part C, then it says using your matrix in part B, find the exact values of x and y here. So where do we begin then? Well, the first thing to note here then is, as we're told here, this point xy maps to this point 5, 6 under the matrix P here. So xy maps to 5, 6 then under P. Okay. So we take this matrix here, right? This applies a transformation. So we have 3, 0, 0, 3 here. Okay. And we apply this transformation here to this point xy. So we can represent this using matrix multiplication here, like so. And the result we get then is this point here, right? 5, 6. We get 5, 6 then once we apply the transformation here. Okay. So what we're going to do now is use the inverse here of the matrix P as we established in part B. And we can use this then to help us find xy here, the original point, right? So in that case then, we can find xy here. So xy here is equal here then to the inverse of P. So P inverse, oops, try again. P inverse times by this point here of 5, 6. Okay. So 5, 6 there, like so. And obviously we know what P inverse is, right? We established that in part B here. So in that case, then what we have here is a product of matrices. So we have 1 over 3, 0, 0, and then finally 1 over 3 there. Okay. And we times this here then by 5, 6, like we've already done with this point here, basically, or at this point, I should say. So we have 5, 6 there, like so. Well, to find this matrix multiplication here, we can either just use our calculator, which is absolutely fine, or we can just do it by hand. It's pretty straightforward, right? I've got 1 over 3 times by 5. Well, that would give me 5 over 3. Then we have 0 times by 6. So 1 over 3 times by 5 plus 0 times by 6 here. We simply get 5 over 3. We get 5 over 3 there. And then doing the same here with this row and this column here, we get 0 times by 5, which is 0, plus 1 over 3 times by 6. We get 6 over 3, which is 2 there. Okay. So we get 5 over 3 and 2. So what this represents here then is x and y. So in that case, then what we can see here is that x is equal to the top number here, 5 over 3. We get x equals 5 over 3. And y here is equal to 2, the bottom number, right? Okay. And there we have it. So that gives us the solution there to question 1. So to finish with here then, let's just take a look at one more question. So we have question 2 here then. And as we can see for question 2, we are given this 3 by 3 matrix. So for this matrix here, what we have then is 0, 0, 2, 1, minus 2, 1. And then finally along the bottom row here, we have 2, 0, minus 1. We're told that the point x, y, z here maps to the point A80 under Q. And for the first part of this question, then part A, it just says using your calculator or otherwise, find Q inverse. So for part A then, I would definitely just recommend using your calculator to find the inverse of the matrix Q here, because we're now working with 3 by 3 matrices here, right? So find the inverse of a 3 by 3 matrix compared to a 2 by 2 matrix is far more time consuming here. So if possible, please do use a calculator here in the interest of saving time. I definitely don't recommend doing it by hand. Okay. So nice and straightforward then for part A here. All we need to do is input this matrix here into our calculator, and then we do Q to the power of minus 1 here. What that gives us then is the inverse here of the matrix Q. So if we do this correctly, then what do we get here? So I get 1 over 4, 0, and 1 over 2. That's along the top row here. I'll put the brackets in a moment, just so I, definitely got enough room here. Then get 3 over 8, minus 1 over 2, and then 1 over 4. And then finally for the bottom row here, we get 1 over 2, 0, and 0 here. Okay. So that gives us our inverse matrix here. And as we would expect, right, we get another 3 by 3 matrix. Okay, so that gives us the solution there to part A. Hopefully nice and straightforward, right? Now for part B then, it says hence or otherwise find the values of x, y, and z. And this is very similar then to the previous question here, where we found the values of x and y. But now for this question here, clearly we're working now in 3 dimensions rather than 2 dimensions. So for part B then. So what we have here then is the matrix Q, right? And Q here just applies a transformation. So we have the matrix Q. I have 0, 0, 2. We have 1, -2, and 1. And then finally 2, 0, and -1. Okay. So this matrix here, this transformation is applied to the point x, y, z here. So again, you can represent this here as a matrix like so. So x, y, z here. And then in that case, what we get here, once we apply the transformation to x, y, z, is we get this point here, A0. We get A0 here, as we've just mentioned. Okay. So what we can do now then is use the inverse matrix here that we found in part A to find x, y, and z here. So in that case then, we can simply find x, y, and z here by doing the inverse of the matrix Q here. We've got Q inverse times by this matrix here, right? A80. So we've got Q inverse times by A80 here. And the result we get then is the original point x, y, z, right? So Q inverse here, we found that in part A. So we've got 1 over 4, 0, 1 over 2, 3 over 8, minus 1 over 2, 1 over 4. And then finally 1 over 2, 0, and 0 here. So let's just write this down in full. So hopefully I'll have just about enough room here. 1 over 4, 0, 1 over 2. I've then got 3 over 8, minus 1 over 2, and 1 over 4. And then finally here, 1 over 2, 0, and 0. Okay. And we times this here then by A80. So we have A0. Okay. So to find this product here then, again, just as we've done for part A here, I would just recommend using your calculator. You can do it by hand. That's absolutely fine. But yeah, using a calculator is far easier. If we just use a calculator here, then what do we get? So what I get then for this product here is I get 2 minus 1 and 4 here. Okay. So now what we found here is the values of x, y, and z. So in that case then, x here is the top number, y is the middle number, and then z is the bottom number here. So in that case then, x is equal to 2, y is equal to minus 1, and then finally here, z is equal to 4 here. Okay, and there we have it. So that gives us the solution there to part B, and that gives us the solution there to the very last question, question 2, and that brings us to the end then of this video here on the inverse of a linear transformation.